Holy smokes, the first time I did this video, right when I was pushing stop to finish, the whole program just died on me. You gotta love it when that happens. So anyway, I've got my star here because stars make people happy, so it's to remind me to be happy, and smiley faces make people happy. And so stars with smiley faces should make people really happy. So this will remind you to be happy while you're working these problems, and it will remind me to be happy even if it shuts down on my face again. So what we're doing this time is we're looking at the modulus functions, all right, or the absolute value. Now we're going to be looking at taking the absolute value of a function and also the absolute value of the x inside of the function. So this is actually not going to be too bad because we're going to just think about it. The first one we're going to look at will be one with a graph. Okay, so this one we're taking the absolute value of the function itself. So I still put the same x values in as usual. I still get the same values out for f of x. The difference is when I get that y value, I'm then going to take the absolute value of it. So any y values that are already positive, they're not going to change. So all of these, those are positive y values. And these are positive y values. So those are all going to stay the same. Okay? Now what we need to do is say, okay, well, all the negative y values are now going to become positive. And so I'm just going to recopy what's down below. And then same thing over here. Now that looks like it's crossing at about -3, so I'm going to make sure it crosses here at about +3. So we'll just go like this. There we go. So there it is, and I think that looks kind of cool. I mean, it's a little bit whack, but otherwise it's kind of an interesting function. But anyway, that's how you do the absolute value or the modulus of the function as a whole. Next, we're going to look at what to do if it's the modulus of just x. Now, remember what this means is I can still put any number in for x, but when I put that number in for x, I'm going to take the absolute value of it before I work the function. So if I put a -3 in there, then it's going to take the absolute value, and it's the same as if I had put a +3 in. So the result for -3 will be the same as the result for +3. So really what I want to do, the 0 should stay the same. Oops. And any results for the positive side should all be the same. So we're just going to copy that on just as it is. Now the result for -1 is the same as the result for 1. And so we're just going to put that point on. The result for -2 is the same as the result for +2. So essentially we just want to then copy the right-hand side as a mirror image on the left-hand side, which would then go up from there. Okay? And so that's what it is. If it's the absolute value of x, it's just that right-hand side recopied because all of those values will replicate because when you put the negative in, it will become positive. All right, let's look at this other one, which is an equation. The first thing we need to do here is do the transformation. And I'm going to take just one extra step because I know that when I'm doing my horizontal translation, I want something, oops, that's not quite right. I want it to be with the x right inside there, the plus or minus right by the x so that I can do my shift correctly. Now in this case, I'm going to go ahead and graph it. You should know how to graph a radical function. I'll go ahead and go all the way up to 9. And from there, we go 0, 0, 1, 1, 4, 2, and 9, 3. So all of those points will be helpful. So there's my original function. So what I'm going to do here is I'm going to do the transformations. So I'm going to first I'm going to do the stretch, which is 3. Now this is a 3 being multiplied by the x on the inside, so that should affect it horizontally. But instead of multiplying, I need to do the opposite, because anything done to x is the opposite. Oops, that -4 should be on the outside. Can't be lazy. So therefore, I need to divide all the x values by 3. So this one that's at 1 will now be at 1/3. The one that's here at 4 will now be at 4/3 will be the x value, and this one at 9 will be over at 3, right? And so I'm just kind of keeping track of the x values there. So 1/3, 4/3, 3, and so it should look something like that. Okay, and then I'm going to shift it. So I need to do the plus 1/3, which means everything needs to shift to the left 1/3. So this point will be at 1/3. This point, which is at 1/3, will be at 0. Okay, so it's going to shift there. The one at 4/3 will be at 1, and the one at 3 will be at 2 1/3. And so it's all been shifted, and you can see that slight shift to the left because I'm adding to x, which is the opposite. Now I need to shift it down 4 spaces. So down 1, 2, 3, 4. This one down 1, 2, 3, 4. Oh, schmack. Got it. This one down. That's at just to the left of the 3. So down 1, 2, 3, 4. So about right there. And so we've got this graph that looks something like this. All right. And at some point it'll probably cross, but I'm not going to worry too much about that at this point because my focus is on the moduluses here. So I need to do the modulus of f of x, which means that all of the negative values will become positive. Any values that were already positive can stay there. So here I don't have anything positive yet, but all these negatives need to become positive. So I'm going to have that one right there. That one will go up to the positive 3. This one that's at the 1 will be right there. And so right here, and again it'll cross somewhere. You could find that if you wanted. In fact, it would be, yeah, it shouldn't be too difficult to find that at all. You just need to find how to get 16. So at x equals 5, it looks like you'll end up crossing. So right there. And that's fine, which means that as you cross that, right, this graph should cross, okay, 1, 2, 3, 4, 5. So this graph would actually cross right there, which means when we do our absolute value, it'll go down, down, down. Once I get here, it's not going to keep going down. It'll actually go back up and follow that one. Okay, keeping the y value always positive because that's what you're doing there. And the last piece, the function of the absolute value of x, which means that I'm just going to take the right side of this, which looks like that, and I'm going to replicate that. So 1, 2, 3, 4, 5. Replicate that here on, I can't ever draw going in the left-hand direction. I'm not an artist. And so it'll just replicate exactly what it is on the other side because all of those negative x values should replicate what the positive x values are doing. Okay, that's the idea behind the moduli or modulus or moduluses. I don't think moduluses sounds right. I think it's probably moduli or something. Anyway, it sounds like something from some type of fantasy fiction book. Beware the moduli. Anyway, we're done. You can go on. Ciao.